Hi, thank you so much for joining in this Tech Talk series with Netpoleon. My name is AJ, and today I'd like to speak with you about Checkpoint CloudGuard Network Security. Provides advanced threat prevention and automated cloud network security through a virtual security gateway with unified security management across all your multi-cloud and on-premise environment. By now, most of us know that our cloud vendors look after security of the cloud, whereas we need to take care of security in the cloud. Usually, attention turned to protecting the north-south traffic, meaning traffic between the internet and those resources hosted in the cloud environment. But what about the traffic between your production, testing, and development environments? If any of these become compromised, malware could spread literally with nothing to stop it. We protect the east-west traffic with full suite of security controls. These controls integrate with the environment itself, so that if new server gets spun up and new environment created, they're automatically secure based on the policy in place. This adaptive security model ensures DevSecOps never comes at the expense of slowing anyone down. And of course, we centralize the management of this protection, meaning you can apply consistent policies across each of your cloud environment while having a single console that covers all of them. Checkpoint CloudGuard Network Security provides advanced threat prevention, security for application and data in private, public, and hybrid clouds. CGNS, or CloudGuard Network Security, is essentially similar to Checkpoint Security Gateway from physical appliance, but adapted and configured especially for deployment on cloud platforms and software-defined data centers. The key features and benefits of this CloudGuard Network Security are: protects cloud security and application from unauthorized access and deny service of attacks. Works with multiple public cloud services, AWS, Azure, GCP, and many more. And software-defined data center solution provided by sample with the VMware, NXX, Microsoft Hyper-V, OpenStack, Cisco ACI, and many more. It also uses a rapid deployment available in all leading public cloud marketplace and supporting a pay-as-you-go and bring your own license model. Development and configuration of CloudGuard gateways takes just a minute, provides specific IT authorized workflow and template that can be leveraged to ensure alignment with the corporate security ecosystem. Agility to a dynamic automated policies integrate with leading public cloud managed solution. CloudGuard Network Security ensure that all cloud-defined elements such as asset, tags, object, and security groups are updated in real time. Centralized management across cloud and on-premise infrastructure enforce consistently corporate security policy with a single management console with a view security events across complex environment and correlate events to application and policy. Consolidation logs and reporting, end-to-end visibility, and enhanced forensic analysis through consolidation logs and reports with a hybrid cloud environment. When designing a secure cloud environment using a CloudGuard network security, it is strongly recommended to use the hub-and-spoke model. In order to achieve the cloud security architecture principle already described in this model, the environment is set up as a system of connection arranged like a bicycle wheel, in which all the spoke and connected to the center broker or the hub, and all traffic to and the spoke traverse from the broker or the hub. With this architecture, the blueprint design can be a single hub or a multiple hub. A spoke is isolated to the network environment that contains collection of one or more network segments from which workload can be installed and run. A common spoke used in these cases several virtual servers that together compromise an application stack, example, web application, database, and other use cases is the spoke that is extension for existing on-premise networks such as the QA server. With this architecture, we have different deployment, single hub deployment, double hub deployment, and triple hub deployment. Single hub architecture acts as center point of the security of the entire cloud environment, with the ingress and egress zone for north to south traffic inspection, the ability to add east-west inspection between BBC, VPN, or MPLS connection, flexible deployment with the template of a single gateway, HA cluster, or auto-scaling. With auto-scaling group, automatic scale and scale with based on the load and performance. Spokes represent a virtual network where different assets are deployed. With a double hub architecture segment, and it's for security control on the traffic entering of existing a spoke. The ingress deployment auto-scaling gateways that handle fluctuating level of traffic from the internet. The egress hub is responsible for the east-west traffic between spokes, outgoing traffic to the internet, and corporate traffic from on-premise data center, and it has flexible deployment option for standalone, cluster, and auto-scaling to meet resiliency and performance requirement. Triple hub architecture offers the most separated architecture and adheres the most of a zero trust model. These architecture segments the different traffic flows with security controls of each hub. The ingress hub deploys as auto-scaling gateway that handle fluctuating level of traffic from the internet. And the egress hub is responsible for outgoing traffic to the internet. The east-west hub handles the east-west traffic between the spoke and the corporate traffic from the on-premise data center. All deployment templates support agile security policies that dynamically learn for cloud subscription through tags and metadata. With Checkpoint, we have different security management components. This used for the Checkpoint integration for security management. Checkpoint Smart Console make it easy to manage security from complex network before you start to configure your cybersecurity environment and policy. Become familiar with Checkpoint Smart Console. CloudGuard network used for the dynamic environment such a public and on-premise data center. And cloud presents a large challenge to security professionals. The CloudGuard controller is a component of security management servers that allow cloud policy to adjust dynamically to change in the cloud environment. It does this by utilizing the identity awareness or checkpoint security gateway to access cloud services provided, synchronizing the current state of the associate account, learning about the objects and the attributes in the data center. In a secure public cloud environment, workloads are consistently in the flux. This environment requires automatic system to allow security gateway to adjust policy and sometimes even the number of security gateway instances to account for changing in order for that occur smoothly. Checkpoint developed the Cloud Management Extension. A CloudGuard managed extension is a utility that runs on Checkpoint Security Management Server or multi-domain management server running in a Gaia OS. The CME allows cloud-native integration between the CloudGuard and the cloud service platform provider. Most of us, we are required to analyze and assess the existing environment of the customer to give them recommendation based on the best practices. Scoping requires the customer type of cloud computing like the private and public cloud. We also need to check the cloud service provider and their private and public cloud. Checkpoint licensing is based on the numbers of virtual cores. The central licensing utility has a pool of licenses for every account. For example, 10 virtual cores license can be used to deploy 5 gateways of 2 virtual cores of each security gateway. And by connecting these gateways through the pool of licensing will be applied automatically. For most use cases for the hybrid data center deployment, many organizations has an on-premise data center Some of them are small and some are quite extensive. But what will happen when the workloads the organization is running outgrow the data center they have? Building a new physical data center or expanding it consume time and resources that might be better spent on the other project. At the same time, this is already a great deal of time and resources invested in existing data center. This is where hybrid data center deploy can help. The distribution of resources differs for deployment to deployment, but there are some components that are universal. The components of hybrid data center are on-premise workload, on-premise security, and connection between the on-premise data center and the cloud database center. Cloud-based security and cloud-based workload can be used for the hybrid data center on-premise workloads. Oftentimes, an organization is rolling up a new initiative or new products for the greenfield deployment. They need a data center to support that project. While an existing data center could be used for such a project, often the existing data center an organization has already fully utilized. This is when an organization deploy a new data center, often referred to a greenfield deployment. Since the operation is being planted in the new ground, greenfield deployment is to build an entire project in the cloud. Power cooling, infrastructure, and space are handled by the cloud service provider. Workloads can be maintained in a virtual server or even be deployed as a serverless applications. While additional people may be required to manage the workloads, application can be managed by the same people who deploy them, reduce the size of the additional workloads. Disaster recovery response for one thing that every security planner recognizes is that disaster will occur, and that they will occur when the organization is at least prepared and capable of handling an event. Disasters can be something as a natural, as a hurricane striking the region where the data center is located, or as a natural thieves stealing the service supply cables from outside of the data center, or anything in between. In order to prevent business impact, disaster and disaster recovery planning are necessary in our organization. Having a disaster recovery site can be part of that planning. Disaster recovery consists of secondary sites that are geographically separated from the main data center site through the degree of separation can be varied from the site located on the other side of the campus, or to site on the other continent of the other site, or within the cloud itself.
Now we will move on in the demo to show you the ease of deploying automated advanced security solution of Checkpoint CloudGuard Network Security. I'm using Microsoft Azure for the installation and deployment of the security gateway. This demo will help you to understand the deployment of security management on SmartOne Cloud and prepare your Azure environment for deployment. So let's start by creating a SmartOne Cloud account in the Infinity portal. Go to the portal.checkpoint.com, click register, and then fill in all the details below. Now I have an existing account, so I will just sign in. I'm using my own account. And then the password. And then click sign in. On the top left, click the menu and then click SmartOne Cloud. Now we'll show you the terms of Infinity Portal and policy. Select I accept and then click try now. And then select get started. And then add the name of the management service identifier for the desired log retention period. And then click create. Now we will waiting for the account to be ready. And then click close. And then we will add new gateway. Click the plus sign. Add the name of the gateway. And click register. We will now create a virtual network on the Microsoft Azure. Go to the virtual network. And then click create. Fill all the details for the subscription and the name. Then clicks next, and then add the subnet, or we will change the subnet default name to front end to identify which subnet will be using in the interface of the firewall. And then we will add back end subnet for the connectivity of the web server. Click add, and then select review plus create. Once the validation passed, select create. And now the deployment is completed. Deploy the security checkpoint gateway. Go to the marketplace and then find checkpoint, network security, firewall, and threat. And then for the demo, we will use single gateway, and then select create. Fill in all the details, the subscription or resource group, the VM name, and the password. Then click next, and then we will fill in the information for the Checkpoint CloudGuard version, or 81.10. The license is bring your own license. The SIC key for the connectivity of management to the firewall, and then click next. Under the virtual network, we will add the My VMnet, and then for the front end subnet and the back end, we will add the subnet we created earlier, and then we will create a new network security group. And then click review and create. And then we wait for the deployment process, and then complete it. Now we will create a subnet for the web server. Go to the Microsoft Azure virtual network, and then select the VMnet, and then add subnet. We will add web and then the IP address of the web. Then after that, we will create a UDR or routing table that is associated in the newly created subnet. Click create routes. Add the resource group, same as the VMnet. Location and the name of the routed table. Then click next. Then skip the tags creation, and then click review and create it. The resource, and then we create routes for the web server. Click add routes. So this will create routes entry, which will direct all the VM related traffic to the CloudGuard gateway. This includes the traffic between subnet as well as the traffic between the instance in the same subnet. Effectively inserted a macro as well as the microservices. Then click add. Now we will add another route a route entry for the default traffic going to the internet to the CloudGuard. And then add another routes for the microsegmentation. This route entry will direct all the internet traffic related to the CloudGuard. Then the next hop IP address. Then click add. This created route stay ineffective until associated with some subnet. So we go to the subnets, click associate, click the virtual network we created earlier, and then the subnet, the web subnet, and then click OK. Then you will see in the overview that the routes is imported. And then let's refresh the page to see the subnet or the associated subnet. Okay. Now we will provision the web server instance from the Azure Marketplace. Go to the Microsoft Azure, click the Create a Resource, find the Bitnam Nginx or Nginx open source package by Bitnam Nami. Then select, and then click Create. And then fill in the info or the details, the resource group, the virtual machine, the region, the size of the disk or the size of the VM, and then the password, username and password. Then click next. Then click next again. Then add the subnet of the web. And then we off the public IP. Select the advanced. And then check the network security group. Then click next, and then click review plus create. Figure the connection of Smart One Cloud to the gateway. So we'll go to the virtual machine, click the gateway, security gateway, and then copy the public IP address. So we will access the virtual machine using a CLI. Open the PuTTY, paste the public IP address, use the username and password created earlier. Then we will go to the portal, login using the account. And go to the Connect Gateway, select Connect Gateway, copy the script, and then paste it on the gateway. So this will create a tunnel from the security gateway to the Smart One Cloud. We'll access the Smart One Cloud. Open the Smart Console using R81.20, and then go to Smart One Cloud, copy the connection token, and then paste it under the Cloud Infinity login. Open the Smart Console, and then go to the gateway and click Communication. Retype the one-time password created earlier in the Azure Marketplace for the security gateway, and then click Initialize. Then click OK, and OK again. And install policy. Let's wait for the policy installation complete. Now we will create a NAT policy, create a NAT rule, and then add original source as the internet. Then create the original destination, the interface of the security gateway. So let's create a host. Name of the host object, the front end interface of the firewall, the IP address of the firewall. Then click OK. For the original services, we will use HTTP. Select HTTP. Retain the stranded source as original. And then create a new host object for the IP address of the web server. This rule will use for the user to connect to the web application server. Then let's go to the gateway and servers. We will change the anti-spoofing, and for the demo purposes, we will disable the anti-spoofing and add the network subnet in the ETH1. Open the checkpoint gateway, go to the network management, select ETH0 for the external interface, select modify, and then remove the check button and then click OK. Then for the ETH1, click modify, change or override the interface, and then change the Azure CGW interface to the network of 10.00 and disable the anti-spoofing. Then select OK. Then OK again. Select OK. Now we change the policy and the configuration to the gateway. We will now install the policy. Select Install Policy. Select Publish and Install. And then select Install again. Let's wait for the policy installation. Now the policy completed. Now we will add another security policy for accessing the web server. So let's go for the access control and then select policy. For the demo purposes, I will change the action of the cleanup rule for accept and then the track to log. And then install policy again. Click Publish and Install. And then install. Let's just wait for the policy installation completed. Okay, the policy installation succeeded. And then let's go to the virtual machine, copy the public IP, and then we will access the server using that public IP. Paste the public IP. And then now, we're now successfully access the Bitnami Nginx open source. For validation, we will check if the traffic is going to the firewall. we'll go to the log and monitor and filter HTTP. And then you can see there's a bunch of logs. And then we will check if this IP address is matched on the logs. And I'm using IP chicken to check or validate my IP address. And you can see that is 9.6.